me double check. Okay. Okay. Good afternoon. Maybe good evening. That depends depending on where you are. And it's Friday again. Welcome to TGI Pulsar episode 16. Today I'm going to kind of share a topic about talking about backlog and storage size. The subtitle is kind of called Understanding Why the Storage of Your Pulsar Cluster is Filling Up. And why I picked this topic again, not again. In one of our previous episode, we talked about the whole master life cycle. But I think still during the kind of interaction with the community and helping a lot of customers and users adopting using Pulsar, I think there's still a bit confusion between backlog, TTL, retention, storage size, and the actual storage usage of your BookKeeper cluster. So there's still a fair amount of the confusion in this kind of area. I would like to kind of use this episode again to talk about mm, the like how Pulsar is actually stored and actually 1 second, let me double check. To talk about like how Pulsar is actually store and store the masters and delete the masters. So for to give people guidance about like how to debug issues in productions and what should be the checklist for you to plan for going production. So this is the whole idea of this episode, and let's get started from just as usual. So we will kind of do a simple week in review and to see what's happening in Pulsar community, and as well as the like there's any like highlights or any upcoming events to share. In terms of like week in review, I think in the past few weeks, there are a couple kind of updates related to Pulsar functions, and as well as I think since GitHub, I think update some of the GitHub Action environment, and the CI is now kind of quite stable, and a lot of the contributors and committers working on improving the build in Pulsar main repo. So you can go to kind of StreamNative weekly. You can check all the weekly updates from Pulsar, and that I think all the change happens around authentication, which I think a bunch of the committers from StreamNative is contributing a big features related to OAuth 2 authentication, and there are also a lot of enhancements going on within Pulsar functions, and as well as the client. And since it has been a while since 2.6.0 release, so we are also planning for cutting a 2.6.1 release to fix bunch of the issues identified in Pulsar 2.6.0. So just watch the community mailing list, and follow us at Twitter that you will know like when the new release is coming out. And the second thing is we publish a blog post that kind of describing the it's a kind of a blog post responding to a conference article like 2 years ago. The part one is a technical deep dive, And we just published the second part this Wednesday, and it covers the adoption, use cases, differentiators, and as well as community. Hope that give you an overview in terms of like how what is the current state of Pulsar project, and how people should evaluate the messaging slash streaming technology when they kind of choosing different messaging streaming technology in the messaging space. And hope this article gives you a guideline that you can check from different aspects. This is the second one. The third one is there's an upcoming webinar, and the webinar is about how to operate Pulsar in production. And we invite like material from Splunk, Joey from Verizon, and as well as Edson, who used to work for Instructure. Both of them have been running and operating Pulsar in production for many years. And I'll be the moderator on running a panel discussion with them. If you haven't registered the webinar, you can go ahead and check the registration link. You can find the link also by going to StreamNative website. You should be able to see there's a save your spot link. You can just click the button, and it would redirect you to webinar registration form, and you can sign up there. It's in 10 a.m. Pacific time on the coming Tuesday. So if you are looking for discussions, talking to like Matteo, Joe, Edson about the best practice experience on running and operating Pulsar in production, definitely don't miss this webinar. It would be very helpful. And if you have any questions, you can reach out to us and submit your question prior to the webinar. And let me also share the MD file in the YouTube chat as well. So everyone can also use that notes link to find the webinar as well. So this is kind of what happened this week in the Pulsar community, and what is going to happen in next week. Uh, so hope that give you an overall idea about things happening in the Pulsar community. And once again, if you are interested in operations and running Pulsar in production, definitely don't miss the webinar. And if the time doesn't work for you, don't worry about that. We will be also live stream the webinar, and it should be available in YouTube for watching after the webinar as well. So go back to kind of today's topic, and I'm going to kind of talk a bit about the many two things like backlog and storage size, but it would kind of combine everything that I have been I noticed when I work with customers or users using Pulsar in production. Hope that hope I can give you an overview and also provide some rules for you to um, troubleshooting any issues related to backlog and storage size in production, and as well as kind of give you a go to production checklist that you should be paying attention to when you config the Pulsar clusters. So the reason I picked this topic is I have seen many questions either in Slack in in Slack channel or in the GitHub issue, or even like when I talk to people directly, those questions usually coming up around uh, kind of like why like storage size is much larger than the master backlog size, because I already acknowledge all my masters. It's a I assume that the storage size would maybe just go down and even go to zero. But from the metrics, I still see the storage size is way larger than the master backlog size. This is kind of the one type of questions that were coming up again and again from interactions in the community. And the second type of a question is also for people who know the answer of the first question, they can they would know, okay, I understand why that would happen, but uh, usually you went to a different situation that your backlog is usually remain really small. Like in this example, there's only 68 masters or entries in the backlog, but the whole storage size is keep growing and never going down. So the question would coming up is why this would happen, and when this happen, what are the actions that the operators or the administrators should do? So this is kind of the second type of the question. And the last type of question is actually coming from a GitHub issue, but I think that is more or less related. Is in Pulsar we have retention policy, we have backlog quota, backlog retention policy, and as well as like these um, cursor rewind or stick operations. Then when we combine these settings together, like in this question is, I have 100 gigabytes retention policy and 1 gig backlog quota. And what is the behavior when consumer use subscription initial position early setting? Is is the subscription going to be reset to like 1 GB earlier, or it would be reset to the 100 GB? So those are kind of the questions would coming up that related to backlog retention and storage size. So I would like to kind of use this chance to maybe like really deep dive into this area and help people understand the storage model of Pulsar. And once you understand the storage model of Pulsar, then you can you can try to answer those questions yourself. And I will also point out what are the tools that you can use for debugging any issues related to like backlog slash retention. So before kind of dipping, before going into those details, uh, in order to understand the storage model, let's get started with some basic concept in case like for people who are new to Pulsar. So Pulsar is very similar as many pub subsystem. It has the concept called partition topic, and each partition topic is divided into multiple partitions. And producer is produce the message to the topic, and consumer forms a subscription to consume the message from a partition. From producer perspective, so for individual partition, is actually an append-only distribute log. So it's an append-only log. And from producer perspective, when it produces the messages, it's actually appending uh, the messages to the end of each partition. And from consumer perspective, it basically read the messages from individual partitions. So this is a very high level concept, and it's very similar as many other PubSub messaging systems. So if you want to really take an abstraction, like to abstract what is the storage presentation that Pulsar present, it's actually a topic partition. And what producer and consumer dealing with this topic partition is actually producer would append messages into append only log. So in this example is if the producer keep producing messages from 0 to 11, it would append 0, 1, 2, 3 until 11. And from consumer perspective, it's it's actually the read the messages from a given position and start scanning the log and reading out those messages. So this is the foundation of a topic partition is actually an append-only dispute log. So in this model is messages are stored once, only once. So that means no matter how many subscription you have, all the messages are stored only once in a dispute log for each topic partition. So that means each partition has is one log, and all the producers producing messages are like appending the message to the log, and the message only store once. That is a very important concept in Pulsar storage model. It doesn't store messages many times for its different subscription, only once. And if we zoom in to this like topic partition, Pulsar when implementing a topic partition, it's not just map individual partition into a file. It's actually break down a partition into multiple segments, and the segment is a new segment is rolled over when the current segments became full. And the condition to judge if the current segment is full is based on time or based on the size. For example, if it's based on size, that means if I keep writing the message to the current active segment until reaching a certain point, like 64 megabytes, then Pulsar will roll over into a new segment and keep writing the messages into the new segment. And the unit stored in a segment is called an entry. An entry is kind of the concept from BookKeeper, but in Pulsar's concept, you can think about an entry is a message batch. An entry comprised of multiple messages, and the batching is done at the producer side. So basically, producer would have a batching policy that would batch multiple messages together and send the message batch to the broker, and the broker would store the whole message batch as an entry into a segment. So this is the kind of the hierarchy of the storage abstraction for a topic partition. And because uh, the the storage itself is actually break down to multiple logical concepts. In order to identify a message within a topic partition, it's using message ID. The message ID basically comprise multiple components like the segment ID and the entry ID within a segment and the message batch index within an entry. So it's not just simple wrong number that as what you can see from a system like Kafka. It's actually use three numbers for identify a messages within within a topic partition. And that's what we call master ID. But in many ways, master ID is actually the offset with partition within this topic partition. So once you have this concept, uh, one thing you want to put in your mind is the topic itself is segment. It's segment based, and that is important for you to understand the storage size or storage model, because later on when we talk about a storage size, we will use the segment concept. Because the messages are not deleted individually based on the messages or entries. It's actually delete segment by segment. And that is a very important concept for you to understand the storage size. So hope this diagram give you an overview of how Pulsar implement the topic partition. Then to kind of keep things simple, a partition is basically an append-only lock, and the messages will append into the list lock. And for each subscription, it actually maintain a cursor on this lock. So the cursor itself, you can think about it's a consumption state of a subscription. The consumption state means from this cursor, I can tell what are the messages in this topic partition are processed and acknowledged, and what are the messages are not acknowledged. In this diagram, that this cursor is kind of simplified as an offset, and that offset is positioned in message 4. That means messages before message 4 are already acknowledged by all the consumers, and that those messages are ready for deletion. In this example, is message 0 to 4 are marked in green. Those messages are ready for deletion. But any messages like published later or after message 4, those are not acknowledged, or those are not acknowledged messages. Those messages will not be. Those messages are not ready for deletion. So cursor maintains the consumption state, and the consumption state is used by Pulsar to tell what messages are ready for deletion, what messages are not ready for deletion. Hence, the second kind of rules for the storage model is Pulsar use a cursor for store the consumption state of a subscription. To kind of simplify or to compare with uh, other meshing system like Kafka, cursor, you can simplify that it's the Kafka offset. So the Kafka offset can tell like what messages are consumed and what messages are not consumed. But Pulsar is a bit different from Kafka. Is the cursor itself, it's not just a simple offset. It's actually beyond an offset. It's comprised of a more comprehensive consumption state. So in this example, uh, in this diagram, I kind of show 4 examples in order to tell a bit about what are the kind of difference of these how Pulsar is actually stored how Pulsar is actually using the cursor to present the consumption state. And Pulsar is using an API called Acknowledge to for the consumer to tell broker that the consumer itself already process and confirm processing the messages. And the acknowledge itself is actually used for updating the consumption state, and which is kind of moving the cursor or updating the cursor. So in Pulsar, there are kind of two type of acknowledgement. One is acknowledge cumulatively. Uh, it's the diagram A. So in this diagram is a cumulative line. So basically, it means all the messages before 9, including 9, are already acknowledged, are already confirmed, and they are ready for deletion. And when a broker receives the accumulative, it will basically update the cursor and move the cursor to the new position, and that the position is the message 9. So this is the acknowledgement. As you can see here, the acknowledgement doesn't change anything in the topic partition. So the message, once they are stored in a topic partition, they will not be modified. The only thing it would change is it would update, Pulsar would update the cursor to change the consumption state for a given subscription. So this is the accumulative. And this model is very similar, exactly same as Kafka, commit and offset. So in Kafka, when you commit the curse, in Kafka, the offset is actually it defines a boundary that messages published before this offset are confirmed to be are acknowledged. All the messages published after that offset are not acknowledged. And then when you committing an offset, it's actually moving a cursor in Pulsar. So this model is exactly same as Kafka. But as I mentioned, Pulsar's cursor is beyond an offset. So let's take a look at what Pulsar actually provide in acknowledgement. Is it provide a mechanism called act individual. In the API is called acknowledge. And the act individual is you are able to act individually. So when you act individually, the cursor would actually keep a section, and the section is called individual delete. That means for this given subscription, this messages is already deleted. This is the individual delete. It's not. It's different from from this 0 to 4. Those are kind of delete by a whole range. So this is the idea of the cursor. It keeps both offset and as well as the individual delete. So in this example, when broker receive ACK individual 7, because the offset here is 4, and the it only acts 7, in Pulsar it would record 7 in the individual delete section. So the whole cursor would actually using the offset in individual deletes to represent the number of the messages that already confirmed to be consumed by this subscription. So understand the how it how it looks like, how it works in the act individual. Then let's take a look at two examples. In the example C, broker receive 3 act individuals, that is 5, 6, 9, and 8. And so because 5 and 6 are kind of uh, are just after the offset 4. So, sorry. So for these operations, it would actually move the cursor from 4 to 6. And because 7 is not acknowledged, then 8 would be treated as individual delete. So after processing those three ACK individual operations, this is how the cursor would look like. The offset is positioned in 6, and add we record as individual delete. And the last example is I receive all four individual X. That is 5, 6, 7, 8. That means from 4 to 8, all the messages are acknowledged. For this operation, it would actually move the offset from 4 directly to 8, and there's no other individual delete. So this is the kind of the idea of using a smarter cursor to record both offset in as well as individual delete that make Pulsar is able to support both accumulative and individual. So this is the acknowledgement part, and that means in Pulsar's kind of in short in Pulsar storage model, the cursor is equals the offset and plus a set of individual delete. And acknowledge operations would tell broker to update the cursor. So this is the storage model. Acknowledgement doesn't delete any messages. It only updates cursors. And that is the important concept. There's no deletion happening when acknowledge happens. So so until now, we know, okay, in Pulsar we have a log, we have a subscription, and each subscription has a cursor to maintain the consumption state. But if I have multiple subscriptions, they both of them, or all of them, want to consume the same set of the data. Each subscription would become just place a cursor in this topic partition. And this would introducing an interesting idea is in this example, I have two subscriptions, and one subscription already processed until 4. The other subscription already processed till to 8. That means all the messages from 0 to 4 are already processed by both subscription 1 and subscription 2. That means from 0 to 4, they are the messages are ready for deletion because all the subscriptions are already confirmed they process the messages. But messages from 5 to 8, only subscription 2 confirm that the messages are processed by itself, but the messages are not subscription 1 doesn't confirm that they have processed a 5 to 8. That means the messages from 5 to 8 are acknowledged by some subscriptions. That means those messages are not ready for deletion. If Pulsar try to delete those messages, it will cause any message loss for subscription 1 because subscription 1 has not consumed those messages. So this is another important aspect is the messages are only ready for deletion after all the subscriptions have confirmed that they process the messages. In this diagram is the messages after the earliest cursor, produced before the earliest cursor are ready for deletion. Any messages after the earliest cursor are not ready for deletion. So this is the Pulsar storage model is all the messages are only ready for deletion after all the subscriptions has acknowledged them. If a message is only acknowledged by one subscription, but still there are some of the subscription are not confirmed has not confirmed that they process the messages, those messages are not ready for deletion. And as you can see here, I still don't use deletion directly. I use messages are ready for deletion. That means when you're moving a cursor, the deletion is not actually happening. Deletion is actually happening much later, but when you update the cursor, it would turn some of the messages into a state that those messages are ready for deletion. So until now, we have a clear picture about the topic partition and as well as the cursors. And to simplify that, I will just remove the consumers from the subscription group. And this would help us to understand a concept about backlog. So what does backlog mean? So backlog means all the backlog actually kind of the backlog is actually at two levels. One is in the subscription level, and the other we sometimes also call topic backlog as well. In a subscription backlog, it's the backlog of a subscription, and it contains all the unacked messages for a given subscription. So for this example, subscription A position a cursor in message 4. That means all the messages from 5 to 14 are in the backlog of subscription A. Similarly, in subscription B, it placed the cursor in message 8. The messages from 9 to 14 are in the backlog of B. Uh, to kind of emphasize here, the backlog here is a logical concept to identify the set of the messages that are not acknowledged. The backlog itself doesn't have any real storage. It doesn't mean subscription A have a backlog. It will store all the messages in a separate location. Uh, Once again, the messages only store in the topic, and the backlog it's a logical concept to define the number of so all the unacked messages for a given subscription. And hence, uh, for a given topic, you would have multiple subscriptions, and each subscription would have its own subscription backlog. And we call the backlog of the slowest subscription is the topic backlog. So in this example, in the subscription A, I have 5 to 14, which is 10 messages in backlog A, and sorry, oops, and the another 6 messages in backlog B. That means for this topic, the topic backlog is actually the 10 messages, which is we are using the backlog A as the topic backlog. And this is basically measure all the unacked messages for all the subscriptions. And that is kind of the backlog. And there are many ways to realize what is the measure the backlog. That there are kind of two metrics. One is the backlog size. That means the total amount of data of the unacked messages. That means in this example is the total bytes of these 10 messages from 5 to 14. Another metrics is the mastery backlog. It's a bit from just from the name, a lot of people will think about this is the total number of unacted masters. But instead, it's the total number of unacted entries. So this is very important. Is sometimes when you try to looking into this metrics and you will try to compare how many messages you have already published into the topic to realize like what are the you're expecting to see the same amount of messages would exist in the message backlog, but in reality is you will see much smaller value comparing to the total number of messages. It's just because the message backlog is actually an entry backlog. It's the total number of unacted entries. And the reason for that is the batching mechanism for Pulsar is done in the producer side. When Pulsar broker receive the whole mesh batch, it will just treat it as a whole mesh batch. It doesn't try to like deserialize the batch and count individual messages, because that would be a very expensive operation and burn a lot of CPUs. So this is the reason why we use like the entries for master backlog, but it also create a certain confusion for people like using use these metrics to monitor its the health needs of a cluster. There's a GitHub issue open to provide a more accurate message backlog. And if you're interested in these features, feel free to comment in the issue. Those two metrics you can get from these Pulsar admin command. You can run topic stats, and you can get the whole topic stats of a given topic, and you are able to see the message backlog for individual subscriptions, and as well as the topic backlog. So this is the backlog stats, and the important takeaway from here is the unacted messages are kept in the subscription backlog, and I say kept. That doesn't mean it's actually be stored in a separate location, but it just means those unacted messages are not ready for deletion. So from observability perspective, you are able to view through a topic stats to see how many messages that are not act in for a given subscription in the topic. So understand the kind of the backlog concept. You will know if a subscription doesn't acknowledge a message, that means the backlog will keep growing. But in reality, is the total storage capacity is limited by the number of the storage node. Hence, you want to set a limitation about like how large a subscription backlog or topic backlog can grow. Hence, in Pulsar, we introduce a concept called backlog quota. A backlog quota defines the maximum unacted messages that can exist for a given subscription when for a given topic, which means which means the backlog for the slowest subscription. So if a topic already reached the backlog quota, when what would happen? So when a producer tries to produce a new message into this topic, that means if Pulsar try to add the message to append the message to the topic partition, it will cause the size of the backlog exist the quota, then it would trigger a backlog retention policy. That means uh, uh, that means Pulsar needs to do something to the backlog, and the backlog retention policy is actually defined with three behaviors. Like the first two is kind of like holding on the producer side. If a master is produced and the backlog already exceeds the quota, the producer request hold, it will basically put the master in the queue and wait until the any sorry the slowest subscription acknowledge the master and move the cursor to reduce the size of the backlog before accepting the masters. So it would hold the request, and from uh, producer side, it was you will end up seeing a timeout because a broker will not append the message to the topic partition, and the producer has to wait the acknowledgement coming back from broker, and you will see timeout happening at that moment. And the second one is very similar as producer request hold. It didn't hold the master. Instead, it would just reject the master. So it would tell producer, sorry, the backlog is already over the quota. Then please, I'm not able to accept this master, and you can. I will send an exception to you. You can wait and retry later. And this is more uh, guarantee that the producer will not hit any problems. The consumer itself will not hit any problems when reach a backlog quota, and will guarantee every masters that produce to the topic will be processed by a subscription. There will be no data loss during consumption. And but sometimes uh, if the subscription is a service that it went down for a long time and you are not able to bring the service back, and you also don't want to block any producers, then there's another operations another policy is called consumer backlog eviction. But eviction means it would automatically move the slowest subscription, the cursor of the slowest subscription, to reduce the size of the backlog. So once it moves the cursor of the slowest subscription, it will mark some of the messages as acknowledged by this subscription, and those messages would be turned into a ready for deletion state. This would reduce the size of the backlog, and Pulsar is able to accept a new messages. So this is the backlog retention policy. And you are able to kind of config in the kind of cluster-wide configuration by setting what would be the default quota and what is the default retention policy. And even you can turn off this backlog quota mechanism. And if you don't want a cluster-wide settings, you can still use namespace policies. So you can set individual like backlog quota policy for different namespace by just using the Pulsar admin namespaces set backlog quota. So the key takeaway here is the backlog quota sets a cap on the unact masters. And an important thing to remember here, the cap is a logical cap. It sets the limit on the total of the total number of the unact masters. It's not a physical cap, and like on the physical disk, but it's actually a logical cap. And another way is, since in the previous slides I mentioned, sometimes when you have a subscription went down and you are not able to bring the subscription back online, that would cause the master backlog keep growing. In you can config using consumer efficient policy for backlog retention, but sometimes your mastery might not be valuable after a certain of time, and you want to make sure all the subscription can read the latest messages. So you want to define a way that is for a given message, the amount of time that is allowed to be stay in the acknowledgement state, and that is TTL. By specifying a TTL policy, that means all the subscriptions, if they don't acknowledge a message within a given time duration, the message will be automatically marked as acknowledged. And once it's marked as acknowledged, then it would be it would be ready for be count for like deletion. But deletion itself, it would depend. All the subscription would kind of move over that message. So this is the TTL, and TTL is usually very useful for some of the messaging application or streaming application that that would require the masters to be really up to date, and they don't want to process any old data, and TTL would play a great role there. So this is TTL. Same thing, you can config cluster-wide setting. You can specify this in namespace. And the most another takeaway coming out for this is TTL defines the time of a master can stay in an acknowledged state. And TTL is expire in sequence. Just remember, it's in sequence. Like if you have a master that might have a bit earlier published time, but it doesn't it's already expired, but the cursor is still not moving over the closest masters. Those masters will not be marked as acknowledged. So the TTL is actually moving the cursor in sequence. Uh, that means TTL itself also don't delete any messages. It only move cursors. When you move cursors, it would change the message backlog and would turn some of the messages into acknowledged state, and those messages would eventually be ready for deletion. So we talk about the TTL backlog and acknowledge. So one of the principle of Pulsar is a message is ready for deletion after all the subscription has confirmed the message is acknowledged. That is good for all the messaging queuing workloads, but it's not good for some of the streaming or even unified batch in streaming workload. For a streaming workload, you usually want to rewind your subscription or your cursor back to an earlier state. So that means Pulsar need to provide a mechanism to keep the data around, even they are all acknowledged by the subscriptions, and that is retention. Retention policy defines the amount of the time that an act message would be kept before deletion. So that is the retention. And the most important kind of thing here is it only applies to act messages. It doesn't apply to unact messages. So any messages in the backlog itself we are not impacted by the retention policy. It would only the act messages are impacted by the retention policy. That is the another important things you need to learn from the Pulsar storage model. Similarly, you can config class-wide setting and specify in the per namespace. So retention policy defines how to handle act masters. It will not it doesn't define the behavior of unacted messages. And when we put all these things together, you can see uh, cursor is actually defined, is a boundary to kind of define messages that are already acknowledged and the messages are not acknowledged. For the messages are already acknowledged, the retention policy would be applied there. All the messages within retention period will not be deleted. Act messages past retention policy are ready for deletion. And any messages that are not acknowledged, they are in a backlog. They will be kept in a backlog until either a backlog retention policy or TTL policy kicks in. And retention backlog policy TTL and explicit acknowledgement coming from subscription would change the consumption state, which would change the cursor, would move the cursor around. That would convert the state of a message from an X state to X state. So those messages would be capable for applying different like policy. So this is the idea, and the most important thing here is kind of maintaining the cursor and also using the cursor to tune how you would expect the data would be kept. The data would be acknowledged. So this is the whole idea of the Pulsar storage. But one last thing here is it comes to in a good question is what is storage size? Storage size, it means the total amount of data that are not deleted. And in a simple way, you can think about that is the amount of the messages, which is the backlog size plus the retained message size. But reality is storage size is not measured in this way. It's actually, remember earlier we talked about Pulsar as a segment oriented design. That means messages are not deleted individually. The deletion is actually happen segment by segment. That means in this example, even 5 and 6, according to the retention policy, 5 and 6 are ready for deletion, but they are not able to be deleted. Then, because in 5 and 6 belongs to segment 2, and 7, 8, 9 in segment 2 are not ready for deletion. That means this segment is not ready for deletion. That kind of change a bit about the retention, I'll say the storage size calculation. The storage size is actually calculated based on the segments. That means even 5 and 6 already passed over the retention period, they are not capable for deletion. That means the total storage size is actually count the sum of the storage size of individual segments. So this is an important metrics because that would kind of answer one question. You usually see the backlog is very small, but the storage size is huge. It's just because there's always one segment active there, and that segment counts. That segment copy a lot of the storage size. So this is the important aspect for storage size. Once again, messages are deleted by segment and segment by segment, not individually, and that changed the way how we calculate the storage size. And when we put message backlog and storage size together, it comes to an interesting idea. Is ideally, storage size should align with the backlog, but in reality, you usually see storage size keep growing, but the backlog remain relatively small, it's because there might be some messages are not act, and those messages would be only those unacted message account in the message backlog. But the storage size is actually measured by the total amount of the data of segments. So storage size is way beyond the kind of the way above the master backlog. And usually you can use topic stats internal to find those metrics. And you can see that the individual deletes messages. Those would be the hole that would cause the storage size growing. And you usually, in order to mitigate the issue, you can usually use topics unload. And when unload happen, it will trigger redelivery. In the client side, you can also set proper act timeout. And the last thing is the storage size in disk usage, but I think we don't have enough time to deep dive into that part. I just want to call out is the storage size doesn't directly represent the usage in BookKeeper. It's just because BookKeeper itself doesn't store individual topic as a file in a BookKeeper. It uses an interleaving structure. That means some of the when some of the segments are deleted, uh, uh, it will cause some the entry log file that does if all the entries of an entry log file are already deleted, then the entry log file will be deleted. Otherwise, it would cause some of the entry log file would still remain like large until all the messages are deleted. And this would cause you might see a storage size is like 1 gig, but you see on disk it's 10 gig. And that is because there's GC not kicking and compaction not kicking to reduce reclaim those disk space. And I can use next episode kind of deep dive into this area, but just remember there's a gap between storage size and disk usage. And to summarize this is the Pulsar storage model is all the data is stored in the topic partition, and acknowledgement, TTL, backlog, quota are all things related to subscription, and those are related to a cursor. When change a cursor, it's actually change the state of a message, whether the message can be deleted or not. And messages are deleted segment by segment, and the disk base of deleted messages are not reclaimed immediately. It's reclaimed lazily. So there's a delay between you actually see the disk went down to 0 when after you delete the topic. There's a gap between the storage size and the actual disk usage. So for using Pulsar in production, you should really check the following settings before going production. That is the backlog quota policy, and specify TTL based on your use case. Specify the retention policy based on your storage capacity. And since the topic, the messages are deleted segment by segment, you need to tune the settings related to storage size. And in order to optimize the disk usage, you need to tune BookKeeper GC settings. So with all these settings tuned, you would have a much better situation on planning the whole storage capacity for your Pulsar cluster for your use case. And we kind of run over a bit time, but hope this gives you an overview of the whole Pulsar storage model and answer some of the question I raised earlier. If it's still not clear, feel free to ping me on Slack or email me or raise a GitHub issue. I'm happy to answer those questions. And I would also confirm this talk into a blog post. And since I think there's still a lot of questions around the Pulsar storage model, and hope this can be a guideline for for you to plan the storage capacity for your Pulsar clusters. And that's all for today. And if you like the TGI Pulsar and like subscribe to our YouTube channel. And if you have any topics you would like us to cover, send us an email or like leave a message in YouTube channel as well. And we are happy to pick up any topics that you would like us to share. And thank you everyone. And enjoy the rest of your day and enjoy your weekend. Bye bye.